One of the things that we discussed in lab that would be important for you to examine is the change that occurred between the A sample, the B sample, and the C sample. Remember that A was just the soil with no treatment, B was the soil spiked with E. coli and Staph epidermidis, and C was the autoclaved soil spiked with E. coli and Staph epidermidis. And what you would like to be able to say is, are there any significant changes in the different groups of bacteria following those treatments? And the simplest way to do that is to kind of just set up a ratio. There are many ways to do it, but this is perhaps maybe one of the first things that you want to try. And you can do ratios of A to B, B to C, and A to C to see what was the change that occurred when you're comparing those samples directly to one another. So the easiest way to do that, and I think I'm only going to do this for 10 to the 5 samples, so where we add the most, where we added the most of the spiked sample. Okay, and so what I'm going to do is just to scroll over here a little bit and put in some headers here. So we'll call this ratio A to B. Ratio A to C. Ratio B to C. And the way that I can do this is I just want to know if I set A to 1. Okay, so A is going to be the starting point, and I divide B by A, then I know did B go up or down in relationship to A. Okay, so here's what we can do. We can click on sample B. Oops. Okay, I'm going to do equals. And here is B 10 to the 5 divided by A 10 to the 5, return. So what this value is telling us is that setting A to 1, so this is B divided by A, since that number is less than 1, that means that B decreased relative to A. If it was 1, that means A and B would be exactly the same, so there was no change. If the number is greater than 1, then B increased relative to 1. If it is less than 1, then B decreased relative to A. And you can simply take that and copy it and paste it down. Okay, and there you see your values. So in this case, let's scroll over here a little bit. I'm just going to copy this, put it over here. So the firmicutes went down in B. Bacteroides were about the same. Acetobacteria went up a little bit. Lectospirae, proteobacteria about the same. Large increase in UrbanMicrobiome, okay, because this is essentially 4 times more UrbanMicrobiome in B than A. And you can keep looking at the other ones. There's another big change here. But again, when these numbers are low to start with, the numbers in the fold changes can be quite large. Okay, so I think you get a little bit of the idea there. Let's look at the ratio of A to C. So let's divide C by A. So here is, go up to my formula bar, C 10 to the 5 divided by A 10 to the 5. Okay. Copy that down. And now we can look at the ratio of B to C. And we'll go to C, oops, equals C 10 to the 5 divided by B 10 to the 5. Control copy, paste that down. So let's just change a little the formatting here so everything's equal. We can put this in bold. I'm not sure why all the new formulas that we put in are going to bold and green, but we can just get rid of that. Turn that to black. Okay, and so here we can see our ratios. One of the most interesting questions would be comparing B to C. So we have the spiked soil in B and the spiked autoclave soil in C. And when you look down this, you can see that firmicutes, because this is C divided by B, went up dramatically. However, many of the other ones are significantly reduced in C. Proteobacteria went up, but we're not surprised because we know we spiked with some proteobacteria. We spiked with firmicutes, so those two kind of make sense, and everything else is going down. So this gives you some information that you can make some interesting comparisons with. One other thing that I'll show you is sometimes it's hard to kind of look at the numbers to, they're big numbers, or there are a lot of decimal places, so it's kind of hard to compare them. So one thing you can do is you can select and you can go to Format, Cells. I don't know why it's not working from the other one. Go to Number, decimal places. Maybe we want 3. Okay, and so then that makes it a little bit easier to look at. And then you can also use conditional formatting, and you can do a color scale. Let's do a blue one here. And this, and then I like to, when you do that, it hides the little grid marks. So I like to have all the grids bordered, so I select on that. And so here you can see, and we didn't want to do this one, so I selected one I didn't want to do. And I'm just going to go to Edit, Clear Formats, back to that. And you can see that the red values are the low values, the blue values are the highest values. So it kind of makes it easier to look through the data to see, okay, these ones are the low ones, these ones are the high ones. So it's about making a heat map, and I can show you a little trick later maybe, so that if you want to get rid of the numbers, so you just see the colors, you can do that as well. But let's hold off on that for a moment. And so now you can kind of see which ones pop out as having changed dramatically in your treatment of, say, B to C, where you're looking at what's the effect of autoclaving on the spiked samples. If you look at the ratios of A to B, you can see, is there any effect on the normal community when you spiked in some bacteria? And looking at A to C, you can, is not necessarily the greatest comparison. You have it in case you want it, but I think the comparisons of A to B and B to C are the most informative. Okay. As I was saying a moment ago, there's a little trick to making this look more like a heat map if you want. And that would be to hide the numbers. You want the values, that's what's dictating which colors you get, but you don't really want to see them. And of course, you could try to turn them white, but then they're still going to show up on the color background, and it's really difficult to kind of match the color of the text and the color of the background so it disappears. So the thing that you can do is you can go to Format, Cells again, move from Number down to custom,